Sound test. Hello world. My name is Stefan, aka the Flashover, and we are continuing building a benchmarking library for Roslyn components. We're still in the middle of our very first task, building benchmarking components for the Incremental generator, which is the source generator version which has been added in Roslyn 4.0, which is compatible with the .NET 6 SDK. We started last time with building types to enable diagnostics, and for the incremental generator case to expect diagnostic in the inspection phase of the benchmark. We will perhaps finish this today, or at least almost finish it, because we will later on need this for other components, especially for analyzers and suppressors. And we will have a look at the two missing pieces of the incremental generator benchmark itself, for the invocation phase, where we actually measure the performance of the incremental generator, which are analyzer config options and metadata reference. So let's jump into where have we been with diagnostics. Let's see here our incremental generators. Let's also open the tests. Let's see if everything is green. All tests are passing. It's always a good start. And I rearranged from the last time the types a little bit. So for what we ended with is building tests for the markup syntax, which is similar to, or pretty much the same as in Microsoft.codeanalysis.testing packages. I had a look, perhaps if I need to use like significantly more amount of time, perhaps it's then better to actually reuse those types. I think they're public in the Microsoft Code Analysis testing package. But since we're quite far here, I will leave it as is. But if there is more significant time needed, perhaps it's worth switching and reusing these types. And this markup syntax looks like so, where we have these set of characters, where after the hash symbol, we state a number, which is basically the ID of this diagnostic, and everything between this colon and the pipe character again is basically is the location of the diagnostic. If it is a warning in Visual Studio or in Writer, this would manifest as a squiggly line or a solid line, and in the output that would show that here we have a warning or an error or a information, or there's also hidden that we don't see, but it's there. And yeah, so we can have like multiples. They can also be nested. I didn't test this yet. We didn't quite need this yet, but we can do this later. So the syntax is either open brace, pipe, hash, number, colon, and then the end is pipe, closing brace. Or the syntax is like, the same again, but for the closing part, we could repeat the number, the ID, the markup location of the diagnostic. This will be interesting if we start to nest them. But perhaps let's come to that later. And this markup parser now should sanitize this string from the markup syntax, so that we actually feed the plain C# code into the generator, into the C# generator driver for our benchmark. And what we should then end up with, because this up here isn't valid C# syntax, it's markup syntax, but what we want to end up with is valid C# syntax. So we want to get the locations that we mark here, but also remove this from the code, which then basically looks like so. We have then our expected code, which is sanitized of this markup syntax, and we expect those two diagnostics, which have the location. So actually I currently do locations here. So then we have the actual location of these diagnostics. Well, we didn't really connect it to a diagnostic yet, but we want to extract the location. So this is perhaps actually the point where to continue to connect the location with a diagnostic. So let's have a look at this test here. Where do we have the diagnostics here? So we have one source where we have here this syntax, and we expect two diagnostics. So far we added the location here and the ID, but I'm not really asserting the location just yet. So perhaps let me actually get this to a failing test. I will move this at the beginning of the line. So now the squiggly, I would expect the squiggly to be here, but this is not how it is. So we actually should have a failing test. but we don't. Not yet. Because the test passes, but we didn't want it to pass. Okay, so let's have a look at the incremental generator benchmark, and in the inspection phase somewhere we assert the diagnostics. With your inspector, we assert the diagnostics. So the context diagnostics are those that we expect, and these are the actual diagnostics that we get when we run the generators and update the compilation. We then have, no, there they are, diagnostics. We want to compare them against. And in here, we don't really... I do have tests for the... Okay, still quite to do. We compare the diagnostics here. So if we have a different amount of diagnostics, we understand that something is wrong, and we print out the number of diagnostics that we expect and the actual, but also we compare each and every diagnostic to each other. So we extract this expected diagnostic and the actual diagnostic and compare them. I still have the location here set to null. So this is now where we must compare the location. Okay, so we do have a location check here, but it's not really doing something meaningful. So for the actual diagnostic, we... How is this not failing? Why is the location of the actual diagnostic null? No, it isn't. So why is this not failing? Okay, something is wrong with this if check here, I believe. So we have an ID. Okay. This shouldn't be an AND, this should be an OR. So if any of these checks goes wrong, then we should let the test fail. And now we have a failing test. So I believe I can actually revert that to what I expect and still have the failing test. Indeed we do. So unexpected ID of diagnostic 1. Okay, so this message is not good. Unexpected ID. Okay, so we now do multiple checks. So let's have the location check. Let's move that down here. And let's say if in the expected diagnostic we actually set a location. I think I declared it as nullable. Yes. So we actually want to assert the location if it is not null, or since it's a nullable of t, we can check if it has a value. If it does, we should compare the locations to each other. Yes, for that I wanted to create a location here, location.create with the location information of the expected diagnostic. Since that's this ad hoc diagnostic, where we now need to, we do have the markup location, need to translate this to a real location. This doesn't really cut it, I believe. Let's have a look at the markup parser, because the markup parser does return a set of locations. But perhaps it should also return the ID of that diagnostic. So let's make this a value tuple where we have the location, or we change this into this ad hoc location. Now let's make this tuple first and let's see how this goes. We have the location and the markup key. So for this list, we have locations and markup keys. And whenever we add to it, we add the location and the markup key that we extract from okay, we don't have that here, so we take here the previous key. Okay. So this is when the end character doesn't have the hash symbol again. So this is what we have here is markup browser tests is this case. And the other one is that case where we have at the end the key again. This is this, we have the hash token again, and where we extract the number. So we have the location key. All right. And then we return that. And we now here return locations and markup keys. And with these, okay, this is where we create the compilation. Guess we need to store these. Okay, we actually return them here. Does this now actually return these? So perhaps if I remove that, we will be using that one. No. I wanted to assign it to this. How does this basically define the same one again? Okay. Let's call these out locations. And before we return locations equals out locations. Oh no, 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 hold on, hold on. That's a closure. Yeah, okay, because you have multiple sources. Ah, yes, you have a closure here. Oh, this is multiple because we also per file. We have locations per file as well. Well, not per file, but per source. Does this need to be a collection of collections? List of, okay, let's see where this goes. Source locations. Let's make this a block. And we add the out locations here. Why is this? Oh, so it's unreachable code because of return here. Yes, okay. String sanitized. Return sanitized. Okay. And then we select that. So this is eagerly executed. So we have afterwards the locations. And yeah, so this is now an immutable array of mutable arrays. This is weird. I will factor this later, perhaps. And then we have here this type begin, and we should, in the initialize phase, we should store these locations. And when we inspect, perhaps we could do this immediately to convert them into something more usable. But I guess they are. Let's create a separate type for that, which also contains the file. Let's create a type called locations. Which does behave like a collection. Well, it should derive from collection actually. It's enumerable of location. And let's use the hint name or path. Let's say path. Let's make it a collection for now. And So we now have an immutable array of collections, of locations. Perhaps this suits a little bit better. Because we don't really need the markup location here anymore. Yeah, so in here we pass in the file path, and the location should also have the file path. So when we add it, yeah, we add the location and the key. So let's make this also of a list of locations. And when we add it, we create a new locations. So that's the collection. Haha, haha. So we need to do this per file. So what's the structure? We have one file or one source text which has multiple locations, and then we have multiple source texts with potentially multiple locations, and this is what we need. So we have one collection of locations per source file, and this is one source file, so this returns one. Yeah. So let's make this a location and I think now we got it, a string path. Because we do create a location out of there already. So let's try this. And so this is no, this is just a list of locations. Okay, I think we wrote just everything because it was all right. Oops, this is code I edited earlier. Yeah, it's just a collection of locations. And in here now, we need to combine that. So let's revert that. That was a wrong thought I had. Okay, so we have here our locations and sanitized return sanitized. And now we add to a list of locations. This is now this new type, which consists of the file path and a collection of locations. Those are, how do you call them? Source locations. And we add to these new locations, which I need this as a type. Well, this is my type. and we add the path. Okay, I called this path 1. Let's convert this into a for loop. Where we go through the sources and we have a, how did we call this here? File path. Which is path plus the index. Let's move the body up here. And here we have the parsed texts. List of. Does this? No, the select does not have an overload which passes in an. Oh, it does. Okay, could have used that one. There's an overload which passes in an index. So this will be then source, which is a string, and the index, I believe. Should be. And we can use the index to create the file path. All right. And then we create the file path and the locations. Okay. Now we have all the locations. And with these, we have from all the source texts, all the locations. Maybe empty. And then we can store these. So this, let's make this our collections. Let's, because a collection of path and locations. So let's actually make this locations output. And assign it down there or up here. Locations is source locations. Okay. And let's store these. Okay, and now in the inspection phase, we have all the locations. So let's pass them in. Because you do need to expect them per file. I was not accounting for that just yet. Perhaps let's create another overload. Which we do have the sources here. And they do have the hint name. Ah, the hint name. Can we connect this to the file path? Actually, we should. But we will come that. We will see that issue in just a second. And we pass in the okay, so we have the actuals, yeah, and our expected is now this locations collection. You have the actual, and here are the expected. Do we need to pass them up here? Do we need to parse again? Something is still wrong. Because we pass in the diagnostics here, not there, but here we extract, here we have the sources. Okay, here we can only have the locations, yes. We need to connect these. I guess we need to make those sources. Those are just the sources. Expect. Okay, I believe I'm hitting a bit of a roadblock here. I will skip this for now. And we'll think about this later on. Let's continue with... Let's start the other way around. Let's do the metadata reference. Because can we pass these already? So in the initialize phase, we cannot pass them just yet, but for the benchmark, when we create the compilation, we actually do this block here. We yeah. So if the user hasn't set anything, then we default to create the metadata reference from here. But perhaps we would also like to have the user pass them. And the metadata reference, when we say create compilation, is an enumerable of metadata references. So let's use this. Perhaps we need first a failing test. So we want to pass references here and then expect some different result. Let's see if the first test is green because I changed a bit of code about the diagnostics. Yeah. Yeah, still have not finished that. Okay. And we expect we could perhaps also expect, so this is source that we expect, if some type is available. So in the in the test generator, somewhere I have the meta, do I have it somewhere? Metadata already. It's just something we can read out of the metadata reference. Display name. Perhaps we can use the display name. Let's display the display name. Oops, close it again. This is the test generator, because this generator basically combines all the providers which are available. And then we can create something out of these. Okay, so here I don't do anything with the metadata reference. I do have a metadata reference here, so let's see if we can, what happens if we use the display name here. Should make this test fail, and it fails because so that's okay. So here is our metadata reference. So it's the .NET 6 BCL. Is it? The core lib, yeah. Okay. Okay, since this is in C, that's difficult to assert. Let's get the last part of it. Or is there some other property that we could use? Is unresolved. There are properties. Let's have a look. Oops. This one. Debug. What are the properties? There are no properties. Let's see, what's the path dot? How do we get the last part of a file name? File dot path dot get file name. And we say name of metadata reference colon. So we would expect metadata reference colon system private qualib. Okay, there is some spacing error. Still not correct. Ah, okay. And some other test is failing too, because this one now as well, metadata reference. Guess expects the same thing. Okay, but now I would like to change that. I hope this works how I planned it. So in here, we would like now to set the metadata references, which are so I want to stay close to this type here. IEnumerable of metadata reference. We call it references. And so we require this for the inspection for the initialization phase. We will add a property. The references. They are nullable, okay. But how do we set them? In the test, there is a package. So this is, I think this was at the very first stream about the benchmarking types. This is Microsoft.code, and this is our testing does it. I think we are NuGet, and I said that I'm quite unable to build this. Well, I still am. But I since stumbled upon this tweet from Jared Parsons, who has released a package in order to create these reference assemblies. So for this test, let's include that package. Again, I will link it then later on in the GitHub discussion. There's also different variations of it. If you only want to have one set or specific sets of the reference assemblies, and I think this is a meta package which contains all of them. And let's jump to the repository. How do we use that? We now basically say reference assemblies dot what we want. That's in this namespace, and we let's say try something net standard. And I hope now that the test fails. I hope. Otherwise, we need to do it differently. It doesn't fail. Also, because I don't use it yet. Yeah, how can it fail? So in the initialize, we now, when we create the compilation, we do get the context. And for the references, if the context.references is null, then we use this default here, but otherwise we use the references. That have been passed from the benchmark, or in this case from the test. Yahoo! Failing test. Excellent. And it fails with it's now something else. That's standard 2.0. Well, okay. I obviously still not fully understood the metadata reference that we have here. So for this, where is the generator here? So we use the metadata reference provider, which is a value provider, not a values provider. So there is only one metadata reference. Well, I need to look that up, why we get the X document thing. Is this like any? Will this fail if we run it again? Let's see. So we now of course need to change it. Why is this just the first? No. The last? Not sure. And it passes. Cool. So that's it. We now enabled metadata references. So there's one last thing to take care of, the config options. So once again, let's have a look at how these are passed. We have here the C# compilation options. Do we also want to pass C# compilation options? We didn't do them yet. Okay. Where do we actually pass in the analyzer config options? But we did. Don't we have this already? Which we have the parse options, not the compilation options. I guess I totally forgot these. Okay, let's have a look at these later. Let's do these analyzer config options provider first. So let's print all the options that we have. So this is okay, I need to look it up how this works. I did this in a different project already, in a generator project. Where we use the options in order to control the generator itself. So it's this Enum info generator that we had a look at some point already. We get the options and we read them through analyzer config options, global value, try get value, and here's some string. So how can we fill these options? How can we provide an analyzer config options provider for the benchmark? How is actually code analysis testing doing that? Okay, why is this failing? I don't know. So we definitely have a test for the Enum info generator tests. .NET 6 is not something wrong with my SDK. Well, let's ignore the squigglies. Do I do something with options here? No, those are the integration tests, not the unit tests. Here are the unit tests. And there's definitely something with options. Should be, at least. Okay, so basically have here some strings and generator configuration. That's a custom type. And what do we do with the configuration? Okay, well, the squigglers doesn't make it all too readable, but we okay, here we have the test state, and the test state has analyzer config files, which is a source file collection. Aha, that's a separate file. But that's a special file, I presume. Analyzer config files. So how can we pass these files to the compilation? Is it for the compilation or is it for the options? Let's see. So if we jump to the benchmark, when we create the compilations, what overloads do we have? Global types, return type. So this is our compilation, okay. So we basically could, must be in the compilation options, which I cannot jump into right now. And the compilation options have, they derive from compilation options. Syntax tree options provider. Which has an output kind, a report suppressed diagnostics, module name, main type name, script name, some usings. optimization level, check overflow, allow unsafe, crypto, delay platform, general diagnostic options. Warning level, specific diagnostic options, perhaps? No. Solver, source reference with solver, metadata reference with solver. If it is in here, I can't find it. There's some with no. Oh, no. Parse options? I would doubt that. How could I find this out? Perhaps if I jump into this package. And see how this is used. Which is the analyzer config files collection. Is it? Does it just have more or less this special file? They just create it like source? Add analyzer config document. Okay. But we don't have to. Okay, that would mean we would need to rewrite the way we create the compilation. We would actually need to have a workspace that we add projects to and that we add documents to. And we can also add metadata references and so on. But then we have like a project. How do we then pass this to the generator? Because that gets a compilation. Oops. That would mean, how could this work? I guess for that we would need the .workspaces project. Okay, I will just scribble here something. Guess we need some ad hoc workspace. Oops. That we add projects to. Oh, we add a solution and so on. But how can we then get the compilation? Well, should be like a project. Or do we say like current solution dot projects? Then we have like one project dot. Oh, this is not a enumerable. We could say try get compilation. Tries to get the cached for this project if it has already been created and is still cached. In almost all cases, you should call get compilation async. Is there also a synchronous overload? And then we get the compilation from that. Okay. So basically, okay, let's see if we can quickly do this. In the benchmark, when we create the compilation, we need to do this differently. We need to create our ad hoc workspace. Now to this workspace, we add a project. So we have one project. Should we allow multiple projects? Let's start with one. We don't need a solution. So we get a name and a language. Okay. Benchmark project. The language is C#. So we have a project. Oh, yes. Add project. I guess we need a project info because we need to add. There we can pass in analyzer config options. Yes. which is a document. This is disposable. And then basically from this project we say, in order to create a C# compilation, rather than that we would say dot get compilation async. But since we are quite synchronous here, we need to say get await get result. We have no cancellations so far. Okay. Let's see if we get this working. The workspace is, when we modify, usually Roslyn is immutable. So if we now modify this project, will this modify this workspace? Perhaps. Yeah, there we can set everything. Okay, let's see if we can. Basically, we need to I call it new. Set the syntax trees, which are documents. So we add a document. It wasn't the syntax root. Okay. So we need to in a syntax root. Well, every syntax tree has a syntax root. So perhaps that's the solution. We have the syntax trees. And for each syntax tree, we add a document to the project. Document receives a name. Source text would also be possible. Let's folders and a file path. Name. Let's convert this to a. Can we convert this to a for loop? No, we cannot. Oh, so because it's enumerable. Document ID. And the name would be benchmark document ID. And from the syntax tree we pass the root. Okay, this I guess is not the most efficient. There is also a source text overload. So perhaps let's do the let's do this one. So we do have our parsed texts. This is a source text. And let's parse that one, so we can say source text dot from, where we pass in the text. All right. And could also pass in a file path. Let's do that. Let's call it .cs. And this returns a document. Do we need to do anything with this document? Well, Roslyn is, now I'm actually not sure because Roslyn is immutable. If we add a document, it says add document. Does it actually add it to the project, and has the project now changed? It should, because it says add. But we will find out soon. Let's run the test and see if we get in the sources actually. Index out of range. Where do we index out of range? In the generator. Okay, there was something wrong. There's something wrong with the compilation. Okay, I'm most likely won't be able to get this working in this stream. Let's see how far we get. Then I need to do some investigation of how to create the compilation via the named workspace, so that we then can add the analyzer config document that we actually want to, which now has the beginner name and some text. And this is how we can pass the config options. Okay, but we need to get all this metadata reference, everything. But if I index out of range exception, okay, let's see if we actually do add documents to this project. Documents. 0. Okay, no, this does not work. So add document returns a document. Creates a new document in a new instance of this project. Well, let's get the other stuff done first. So we can say project dot with compilation options, because we have them here. We can say dot with metadata references, because we have them here. And we can say with pass options, because we have them here. And we can say with project reference. Okay, so we could create a project which refers to another project. And with assembly name, because we actually have it here. Okay, so now this is immutable. We need to definitely assign this to a new project. And how can we add a document? I believe did something very similar with, I have a déjà vu, when I did benchmarking for analyzers. So that is diagnostic analyzers. So we will now basically have a look at a future episode where we, since I wrote something, but all this benchmarking I wrote already, I just want to put it into a nice package. And here I do create documents and such. So let's see what I did here some time ago. I can't quite recall. So in order, okay, here he actually create a solution. What's like okay, how does this benchmark work? So in the initialize, it's actually async. Okay, so I guess we need async overloads as well. Well, I only allow one source file, so we create the source, and from that we create a document. I create a project ID. Also create a solution, which with an ad hoc workspace, the options, okay, and then I add the project. And add a document. Okay, but we do create here project IDs. Okay. In a new instance of this project, but it returns a document. So how can I get the project actually? I can't. Okay, so I don't really understand this. Well, this is perhaps just to create a document, but I haven't added it. So we do have the source text. Okay, so we need to create a document. Jumping to the other project, how do we create IDs of the project? Okay. And then add project. I use the ID overload. That creates a solution. I'm doing it on the solution. Okay. Adding a document to the entire solution. Actually, I want to add it to a project. So, but the document is within. The document is within a project. I see. That means we have our project. And we want to add documents to this project. No, now I'm here again. No, to the solution. Yes. Okay, so this project has a project ID. So we do need a solution. Okay, this project has an ID, yes. And to the workspace, jumping back one last time because we also create a no, we don't create a solution, do we? We use the solution from the ad hoc workspace. I'm trying to understand. So on the current solution, okay, we call add project on the solution. Okay, so we have a workspace. We say dot solution on which we create a No, I still have not understood it, obviously. What's project info? Project info is Okay, I didn't do this like for a year. I need to refresh my mind. So project info, okay. Project info consists of documents. We can say create. But this takes quite an amount of. Okay, there's a simple overload where everything is now optional. Okay, we have the workspace. We want to add a new project to this workspace. Perhaps we should do this at the very end. And until here we set up, for every source text we need to create a document. How do we create a document? We create a document ID. Okay. Document ID dot create new ID. Now this requires a project ID. So let's create a project ID. Project ID requires a debug name. Benchmark project 1. Well, 0 based 0. So this is our project ID. And we will use that one and do this, what we tried here. So this will be the debug name for this document ID. But that's just a document ID. Document index. And we want to, for the current solution, add a project with the project ID that we created. Also, no, I do need this beforehand in order to create a document. So the documents link to a project links to a solution. And we add this project. Now for this project, we do what we did here. What do we need for the project? Oh no. Yes, project ID. It also needs a name, an assembly name, and a language. Okay, so name project. can't we take this from the ID? Name, benchmark, project, assembly name. We have that up here somewhere. Yes, assembly name. And the language is language names.C#. And we can't with parse options here. So add project returns a solution, not a project. But that's all right, isn't it? So let's, okay, let's do it like this. So the result is a project. We had a project. Do we have the name project already? Yes, let's get rid of this. And the project has an ID that we add the documents to, and this does not work. Ah, yes, it does. Okay, so now we have the project. But this project is not part of the solution, but I don't mind that because we need the project here. Okay. And for every project, I need to add the I believe we need the solution here. Project ID equals project ID dot create new. Which takes a debug name. Okay. And we add that project. Name, assembly name, language. The debug name is not public. And we yes, with project. Okay, so we don't do with parse options, but with project parse options. Okay, and I guess this also takes the project ID and the parse options. Yes. Okay. And with project metadata references, where we pass in the project ID and the references, and with project compilation options, where we pass in the project ID and the compilations options. Okay. And now we need to add documents. Solution.current solution. Oh no, that's from the workspace. Yes, solution.add document. There's also that documents. And add document gets a document ID, a name folder file path. Okay, so we do create a document ID, okay. But we need the project ID. We do have a project ID. So we pass in the document ID. In name, a text loader. Uh-oh. There, this string text. Ooh, we can pass it as a text directly. Okay. But we can also do it like this. So we have no folders. Do we have a file path? No, we don't. Let's leave that out for now. What does this return? A solution again. Okay, so let's assign this to this solution. Now we added documents. How do we get the project out of the solution? We have the solution dot projects. It's an enumerable get project with the project ID. Yes, we have that project ID. And from the project ID, we get the compilation. Perhaps. Perhaps this works. Value cannot be null. Okay. So we always need to create some C# compilation options. Actually want to make them, does it make sense to pass them to the benchmark? Perhaps it does. So let's make them as parameter. Property C# compilation options. Oops, options. If the user has passed some. If they are null, we create some default, otherwise we use these, okay? Actually, there's a shorter syntax for there, isn't it? If we say use context options, otherwise create new. With the null conditional, no, null coalescing operator. This can even be further shortened with the null coalescing assign. So no, but no, we assign it to a new one. That's init only, is it? Yes. Okay. And we have these options. They should no longer be null. Value cannot be null. The pass options here could be null, okay. So those are compilation options, but need to do the same for path options. Equals, if the context has path options, we use them, otherwise we create new paths, or paths C# path options dot default. Is there also a C# compilation options dot default? No. Okay. Now we fail because the value cannot be null still. Let's see where we fail. Ah, yeah, my bad. I need to pass in those null coalesced path options. And the test turns green. And all the tests turns green. Cool. So we have restored the previous functionality of creating a compilation, but not via the C# compilation create, but we go through a solution, and to which solution we should now be able to pass in options. Can we say like dot with project analyze references with project analyzer options? No. Where did we find these? With config. Config document text. I can't recall where we added these. Project P. The analyzer config document. Ah, there is. Okay, cool. There is a with analyzer config document, but that requires a document ID. But the document ID. Okay. So we could, for each, through some options or config options. We have a config option, and we go to the solution and add analyzer config document. And the analyzer config document, of course, is a document ID. Document, no, not of course. Well, of course, yeah, but this is quite super fresh for me again. We create a new ID for this project that we have, and we call that benchmark config document. We may have multiple. And we pass in a name. Let's use the same. Not sure if this is correct. And the source text. Okay, but now, yes, now we need to create this text. So config options, it's basically a string. So we can go to the context, add another, let's make it enumerable for now, string, which are the, let's make a collection just with sources here. Collection of string. Config options. And for each context options, get a config option and pass this through. Okay, but how do we format them? I need to look up one more time to the previous project. Where in a test diagnostics, no, that's not in analyzer actually, it's in the generator, my bad, it's in this project. Okay, we basically pass it as a global config. Let me grab that. And for the test, we now do the config options and we add this is string, pasting it in. How do we assemble that? So it's, oops. Is global is true, new line, and then I have some config value. My config option. And let's set it to true. And now, if we go to the source generator cookbook, it says somewhere how to read configuration. And let's do this in the test. No, in this test generator. So we context analyzer options, global options. I will grab this if. So we jump to this test generator. Somewhere I have the placeholder of the analyzer config options. So we want to add them. Let's have a look if we can like inspect them as a collection or something. Maybe we can print all of them. No, not really. It says count 0. That does not look promising. Did we do something wrong here? So we do have the config options, and we add them to the solution. Document ID, and the document ID is connected to project ID. Yeah, this is the same how we do it with a document. Then if we get this project with the project ID, we have analyzer config documents. But perhaps I don't understand analyzer config documents correctly. And then I was hoping that in the generator we can get them, but it says backing 0. So do I still have this? Yes. So if you try to get the value, how did I call it? My config option. Try to get that switch. And let's print that. Basically, if switch equals to true, yep, it's basically just print the switch. Oops. But this seems to be, it's actually a value, config value. Must be an absolute path to an editor config file. An absolute path to an editor config file, which means we need to, when we add this in the initialization phase, can't give this the name. This is a debug name, okay, but the name should be /editor config. Is /? You still get a because there's the file path. Folder null, file path, editor config. I hope. No. One generator crashes because must be an absolute file path to an editor config file. Parameter, path to file. So I believe this doesn't seem all right. Let's have one last look at how we did it with this one generator project where we test this. Don't I have this here? No. It's not here. Where do I add the configurations? Okay. This should be the path. Global config. Dot global. What did I do wrong? Oh. It should lead with a dot. Or should it be dot editor config? Perhaps it should be dot editor config. Oh. Ooh. Okay. So that's valid. But we still don't have it. I wanted to jump into the, yes, okay. We never had this breakpoint. So we still don't have this configuration value. So the global editor config, we had a look at this in a previous episode. How do I get there? Net.net analyzers, SDK. Yes. Where we can configure, there's two configuration files. Either we do it with an editor config or a global analyzer, global config. So I like to use the editor config for style and the global config for analyzer configuration. Let's see if we have some global options. If there is some, backing still says 0. But let's try to add like both formats. Let's try to add in global config and also an editor config. Okay, but for the global config, there was like a rule. The global config needs to start with is global true. But the edit config does. Okay, the edit config needs a section. Let's try to document ID 1, document ID 2. Let's try both. Actually, yeah, let's try. Let's try both. So for the test, we just add this configuration value. But for the benchmark, let's try to add both versions. Text 1, text 2. Text 1, let's try to do the text 2 will be the global config variation, and text 1 should be the editor config variation, where we pass in the section. So it requires a file, some file. What's the name? Pattern. And this option. Let's try both. If this doesn't work, I need to look up on how to add a configuration value in Analyzer. Configuration value. Let's have a look if the texts look valid. believe this is a valid editor config. Well, I guess we could also, usually an editor config also has a, let's have a look at one editor config. Actually using one in this project, which looks like, oh no, I want to see the raw file. Visual Studio has an editor for that, so this is the raw file. It starts with root is true. Let's do the full thing. Then we have a file ending section and the actual configuration. Okay. And the global config is, have a look at the documentation. Yeah, so this is an editor config, root is true. Or, well, root true means that it stops searching parent editor configs. And the global config starts with is global is true. But has no, doesn't have this file section. So how are they called? Section header, yeah. Editor config does not have section headers. The editor config has section headers. The global config does not have section headers. The global config is this global analyzer configuration. And so this looks like an editor config file. This looks like a global config file. And if we add these, do we have anything? Counting still says 0. Okay, I'm definitely doing something wrong here. I need to look up what I'm doing wrong here. So we do not have this configuration value. Okay, I'm looking at the time. We are in almost exactly 2 hours. And this could be a great moment to stop because I need to do some research on both how to add the config options and how to finish with the diagnostics. I obviously still haven't thought this through. And this looks like the last 2 steps in order to enable benchmarking and later on inspection of the incremental source generators. If we have a look at this test generator, here we add all the providers that are available. And let's go through them. So we are syntax provider, so we are able to set different sources. We are able to set the compilation, the C# parse options. We can add additional text. This is still a to-do, the analyzer config options provider. We will finish this next time, which may be last time of the incremental generator journey. Metadata references, we got these, and that's pretty much it actually. So, and the diagnostics, okay. Because when we have a look at the invocation phase, or the inspection phase actually. So the invocation phase, when we have the analyzer config options, then we're done with the invocation phase. And we can configure everything which is relevant to the source to an incremental source generator. And for the inspection phase, we still need to deal with the diagnostics. So those are the last 2 steps for next time. And then I guess we can release this package as a preview version and use it in action. I will then start replacing it because if I jump to the generator project that I showed earlier, which has the which doesn't compile for some reason, but has an enum input generator, so which basically does from an let me zoom here. Yes. So if we have an enum, now everything is red. Let's pick a different color: blue, bad, green, purple, pink. If we have a log level none, and we want to toString it, then you could either toString it directly or via the BCL's enum.getName. And this is a source generated version, which is faster. I showed this last time, which basically does a switch on the enum values, on the enum constants here. And because it avoids reflection, is measurably faster. And in here, I also have some benchmarking. I have here the measurer, which is quite similar, where we have the invocation phase and the inspection phase. And basically this can all go away then and be replaced with the package. So this will be then the first use case. All right, that's pretty much an hour. 2 hours, sorry. And let's see, where are we? In today's session, we accomplished the metadata reference. We quite did not end the diagnostics yet. We will do this next time, and we need to finish the analyzer config options as well. I need to do some research on what to set in this ad hoc workspace or in the project or the document in order to enable them being passed to the source generator. Yeah. So we will do this in a week, pretty much in a week from now, minus 2 hours. And all the links that we had a look at, I will add to this discussion, as always. And with that, I want to thank you very much for staying a while and listening for these 2 hours. And yeah, have a great time. Goodbye.